In the study of translational motion or in linear motion, the most important concepts are the displacement, velocity, and acceleration. And all of these concepts has its counterpart in rotational motion, yung tinatawag natin as the angular quantities, the angular displacement, angular velocity, and the angular acceleration. The unit of angular measurement is radian, and this radian is essential to deeply understand the concepts of the angular quantities. In this figure, we can recall that yung distance around the circle, yung distance na yan or tinatawag natin also as the circumference. So we have a formula for the circumference. We have 2 pi r, where r is the radius of the circle, and dividing both sides by the radius. So if we divide both sides by the radius, so r, cancel ito. Etong quantity na to is dimensionless because both yung s and yung r or the radius have dimensions of the length. Pero yung value ng 2 pi corresponds to an angular displacement around a circle. So half a circle would give an answer of pi, half a circle, and that is 180 degrees. And yung quarter circle naman is pi over 2, 1/4. So yung numbers na 2 pi or yung pi over 2 correspond to angles 360 degrees. So 2 pi is 360 degrees, pi is 180 degrees, and yung pi over 2 naman is 90 degrees. So a new unit of angular measure, yung ang tinatawag natin na radian, can be introduced with 180 degrees equals pi radians. So we have a factor here, 180 degrees equals pi radians, relating degrees to radians. So if we convert degrees into radians, ito ang gagamitin natin. In angular position, when we describe the motion of an object or a particle as it moves in a circle, it is convenient to use the angle theta from the positive x-axis to describe the particle's location, as we can see in this figure. And that's because the particle travels in a circle with a fixed radius r. Ito yung r. Specifying the angle theta completely locates the position of the particle. Thus, we call the angle theta as the angular position. I-describe natin yung angle theta to be positive kapag counterclockwise from the positive x-axis, and an angle measured clockwise naman from the positive x-axis has a negative value. So take note that in rotational motion or in circular motion, yung words na clockwise and counterclockwise are analogous. Pag sinabi natin clockwise, left of the origin, and kapag sinabi naman natin counterclockwise, right of the origin in linear motion yon or in translational motion, which we associate with negative and positive values of, say, variable x. So instead of measuring angles using the degrees na unit, mathematicians and scientists usually measure the angle theta in angular unit of radians, yung nabanggit natin kanina. So again, in this figure, pinakita dito yung S, ito, which is the arc length, the distance that the particle has traveled along its circular path. And we define the particle's angle theta in radians in terms of this arc length and the radius of the circle. So ito yung ating equation for the angular position. Theta in terms of radians, so ito, take note that this is radians, equals the arc length over the radius. So this is a sensible definition of an angle. The further the particle has traveled around the circle, mas malaki yung angle theta in radians. So yung radians, pwede natin siyang i-convert into revolutions or pwede rin sa degrees. And we have a conversion factors for those units, revolutions, radians, and degrees. So we have these factors. 1 revolution is equal to 360 degrees, and 360 degrees is equal to 2 pi radians. Or simply, directly, kung radians or revolutions, 2 pi radians is equal to 1 revolution. In our previous problems, and sa mga itatakal pa natin na problems, we often specify angles in degrees. But take note that yung unit na gagamitin natin in this angular formulas is the radian. So, pwede natin i-visualize yung angles in radians by remembering that yung 1 radian is equal to 60 degrees. Next, the angular displacement and angular velocity. For the translational motion or the linear motion na napag-aralan natin sa kinematics, a particle with a larger velocity undergoes a greater displacement in each second than one with a smaller velocity. As we can see in this figure, naman, pinapakita dito yung particle undergoing a uniform circular motion. So, itong particle na to, makikita natin that gumagalaw lang siya slowly around the circle. It has gone only 1/4 of the way. Naka 1/4 lang siya ng buong circle in 5 seconds. Now, for example, we have another circular motion here. Ito. And yung particle naman natin is umabot hanggang dito sa part na to in just 5 seconds. Itong figure na to, yung particle undergoes twice the angular displacement nitong motion nito during each interval, yung 5 seconds interval natin. And yung kanyang angular velocity, yun yung angular displacement through which the particle moves each second is twice as large, doble yung kanyang laki. So for the counterpart of rotational motion sa translational motion or linear motion, ang formula natin for the velocity is v equals delta x over delta t. Yung angular velocity naman as dinidefine natin as omega, so this is the lowercase of omega, ito equals the change in angular displacement or change in angular position over the time interval. Ang unit natin for the angular velocity is radians per second. Take note that itong angular velocity natin ito is constant for an object or for a particle moving with uniform circular motion or for a rotational motion. For angular acceleration, imagine the wheel of a bicycle, gulong ng bisikleta. Kung ipupush natin yung edge nun, it begins to rotate. And if we continue to push the wheel, it rotates ever faster. Mas mabilis yung magiging kanyang rotational motion. Ibig sabihin nun, nagbabago yung kanyang angular velocity. And to understand the dynamics of rotational motion of objects or simply rotating objects, we'll need to be able to describe this case of changing angular velocity. Ang equation natin or the formula natin for the angular acceleration is alpha. So, ito yung ating symbol kapag angular na yung ating acceleration. Alpha equals the change in the angular velocity over the time interval. Again, we use the symbol, ito, the Greek alpha for an angular acceleration. And dahil yung units ng angular velocity are radians per second, ang unit naman ng angular acceleration is simply radians per second square. Now, take note that we have to be careful with the sign of the angular acceleration. Just as with the linear acceleration or the translational acceleration sa napag-aralan natin sa kinematics, positive and negative values of the angular acceleration or the alpha can't be interpreted as simply speeding up or slowing down. Like the angular velocity, yung angular acceleration alpha is the same for every point on a rotating body or rotating object. We have a table here for the relationships of the translational and the rotational motion. So we have here the displacement, velocity, and acceleration. So for translational, usually ginagamit natin sa displacement is x lang. Pero sa ibang references, they use s. So the displacement in rotational, ang rotational counterpart niya is theta. And ang kanyang relationship nito and ito is x is equal to r times theta. Ganon lang din sa velocity and the acceleration. Ito yung kanyang relationships that we have to remember. Example number 1. A wheel 90 centimeters in diameter turns through an angle of 190 degrees. How far does a point on the edge of the wheel travel? So the first step is to find the equivalent of 190 degrees in radians. Theta equals 190 degrees. And gagamitin natin yung factor kanina. Pi radians is equal to 180 degrees. So we can cancel out the degrees. And ang theta natin is equal to 3.316 radians. So this is our angular position. And ang radius ng wheel is 45 centimeters. para makalculate natin yung S, for example, ito yung ating wheel, ito yung starting point, napunta siya, say for example dito, ito yung kakalculate natin na S. And ang formula na gagamitin natin is yung theta equals distance S, or yan yung arc length over the radius. Calculating for the arc length S, r theta, substitute the values, ang r natin is 45 cm, times the theta, we have 3.316 radians. By calculating, ang S natin is equal to 149.22 cm. So, ito yung maaabot na distance nung point dun sa edge of the wheel kapag nag-rotate siya or kapag nagkaroon siya ng angular position na 190 degrees. So, this is example number 1. A 95 centimeters diameter wheel turns at 135 revolutions per minute. Letter A, calculate the angular velocity of the wheel in radians per second. And letter B, calculate the linear velocity of a point on the rim of the wheel in meters per second. For letter A, kailangan natin yung angular velocity in radians per second. Given na sa atin yung angular velocity, kaya lang in terms of revolutions per minute. So we just have to convert it. The angular velocity, 135 revolutions per minute. Convert lang natin. 1 revolution is equal to 2 pi radians. And 1 minute is equal to 60 seconds. Cancel nito. And by calculating, ang angular velocity natin in radians per second is equal to 14.137 radians per second. For letter B naman, we have to calculate the linear velocity or the translational velocity of a point on the rim of the wheel in meters per second. So, gagamitin lang natin yung relationship na given kanina na naka-table. Take note na ang diameter ng wheel is 95. Kailangan natin ng radius. Ang radius natin is equal to 47.5 centimeters. And to calculate the linear velocity, yung relationship, we have the radius times the angular velocity. Substitute the values, r, convert natin into meters. We have 0.475 meters times the angular velocity na 14.137 radians per second. And by calculating, ang linear velocity natin is equal to 6.712 meters per second. So, for letter A, kinonvert lang natin yung given na angular velocity na 135 revolutions per minute into radians per second. In letter B naman, ginamit natin yung relationship ng translational and rotational motion. So, this is example number 2. Example number 3, a metal cylinder with 100 mm diameter is to be machined in a lathe. Calculate the number of revolutions per minute should the cylinder rotate if the required linear velocity of its surface is 1 meter per second. So, to calculate the number of revolutions, from the formula na linear velocity equals the radius times the angular velocity, ito yung gagamitin natin. Ang radius natin is 50 mm. Take note na ang diameter natin is 100 mm. So, ang radius natin is 50. So, we have to convert it into meters. This is 0.05 meters. And we have to calculate the angular velocity. Linear velocity over the radius. We have 1 meter per second divided by the radius na 0.05 meters. Angular velocity is equal to 20 radians per second. Now, to calculate the revolutions per minute, i-convert lang natin siya into angular velocity pa din, but in terms of revolutions per minute. So, angular velocity is equal to 20 radians per second. This is, radians is 2 pi radians. This is 1 revolution. And 1 minute naman is 60 seconds. By calculating, angular velocity is equal to 190.99 revolutions per minute. Or kung ang tinatanong sa atin is yung mismong number of revolutions kada minuto, say n na lang ilagay natin, we have 190.99 revolutions. So this is example number 3. Example number 4, a 5-second duration is required for an engine to go from its idling speed of 600 revolutions per minute to 1,200 revolutions per minute. Calculate its angular acceleration. So simply, ang gagamitin lang natin dito is yung equation natin na alpha or the angular acceleration equals change in angular velocity over the time interval. Kaya lang, we have to convert muna itong given sa atin na angular velocities. The initial angular velocity, so again, from the idling speed daw na 600, ibig sabihin yan yung initial angular velocity, 600 revolutions per minute. So 1 minute is equal to 60 seconds and 1 revolution is equal to 2 pi radians. Ang initial angular velocity natin is equal to 62.83 rad per second or radians per second. And for the final angular velocity naman, 1,200 revolutions per minute. So again, same process ang factor na gagawin natin. Final angular velocity is equal to 125.66 radians per second. And to calculate the angular acceleration, the change in angular velocity is simply the final angular velocity minus the initial angular velocity. We have 125.66 radians per second minus 62.83 radians per second divided by the time interval na 5 seconds. And by calculating, angular acceleration is equal to 12.566 radians per second square. So this is example number 4.